Imagine an artificial intelligence that's actively writing its own code just to make itself run faster on a physical silicon chip.
Right.
And now imagine that exact same intelligence being poured directly into the actual concrete foundations of a sprawling server farm.
Yeah, it's
And
wild.
finally, picture that system embedded right into the prescription glasses, sitting on your face, silently watching and listening to everything you do.
Hmm.
I mean, that isn't a pitch for some dystopian sci-fi movie set in 2040. That is exactly what Meta just shipped in the last 7 days.
It really is a profound shift. We are officially watching AI, escape the digital sandbox of a browser tab.
Yeah.
The technology is moving from something you actively sit down and use to something that just constantly surrounds you. We're witnessing this raw transition into ambient computing.
Okay, let's unpack this. Welcome to the deep dive.
Al.
Today, we are focusing exclusively on a single, frankly staggering week for Meta's AI ecosystem.
Truly staggering.
We're zeroing in on the updates published between March 29th and April 4th, 2026. This is, the pivotal week where Meta's AI moved from the server farm right into our physical infrastructure and directly onto our faces.
Yeah.
We've got a massive stack of sources today: engineering blogs, global press releases, financial reports, and some highly sensitive leaked internal documents. And our mission is to cut through the noise and show you exactly what this all means.
What's fascinating here is how these seemingly entirely different updates, like releasing massive open models, completely overhauling their custom hardware strategy, facing unprecedented legal scrutiny, they're not actually isolated events.
Right.
They represent a single, highly cohesive push toward what Meta's leadership is now calling personal superintelligence. Every single piece of this puzzle is connected.
And, I mean, to understand where Meta is going with this superintelligence,
Yeah.
we have to start with the raw brain power they just unleashed on the world.
Absolutely.
I was reading the coverage from AI Business and TechCrunch from April 3rd, and the headline is that Meta officially launched the initial models of its Llama 4 family.
The Maverick and Scout models.
Exactly, Maverick and Scout. And they're built on this mixture of experts, or MOE, design. They feature native multimodality, and they were trained on a mind-bending 40 trillion token corpus.
Yeah, that 40 trillion token number is just staggering.
It's huge, right?
To put that in perspective for you, we have essentially exhausted all the high-quality human text available on the public internet.
Wow.
Right. So to hit 40 trillion tokens, Meta had to rely really heavily on synthetic data.
Which means?
That means using older generations of AI to generate, curate, and just endlessly filter training data for the new AI. It sets an entirely new baseline for what an open weight system requires.
Right.
But, the real mechanical breakthrough here is that mixture of experts architecture.
Let me actually try an analogy for this, because MOE can sound incredibly dense.
Go for it.
So a traditional older AI model is kind of like standing in front of a giant stadium full of people and asking a question. Every single person in that stadium has to think about the answer and shout it back to you at the exact same time.
Sounds exhausting.
Right, it takes a massive amount of energy. But a mixture of experts model is more like a massive university.
Yeah.
You don't ask every professor on campus if you have a specific math question. The system acts like a receptionist and routes you only to the math department.
Yeah.
You only consult the exact experts you need.
That is a perfect way to visualize the mechanism. In a MOE system, this really sophisticated routing algorithm activates only a specific subset of neural networks for any given prompt.
Okay, so what does that mean for the size of these things?
Well, for their flagship Maverick model, it has a colossal 400 billion total parameters.
Wow.
But because of that university routing system you mentioned, only about 17 billion are active during a single query.
Oh, wow. Okay.
Right, so that drastically reduces the electricity and the computational cost required per generated word, while actually improving the model's ability to handle complex multimodal reasoning.
Like analyzing text and code and images all at once.
Exactly.
But see, here's where I kind of have to push back a little on Meta's whole philosophy.
Okay, what's the issue?
They love to champion open source AI. But if the Maverick model is 400 billion parameters, does that really still count as open?
Yeah.
I mean, you and I can't just run that on a laptop at home.
Yeah.
Only massive tech enterprises with dedicated billion-dollar data centers can actually afford the hardware required to download and run something that gigantic.
That is the defining tension of this entire release. The algorithms themselves are open, yes.
Right.
But the physical infrastructure required to utilize them is highly exclusive. Llama 4 effectively pushes the deployment of these frontier models completely out of the consumer realm and strictly into enterprise-scale data centers.
Which actually bridges perfectly to something else I saw on the Meta Engineering blog on March 30th.
Oh, the BOxCrete thing.
Yes,
Yeah.
because Meta isn't just optimizing the software inside the data center. They are literally optimizing the actual physical concrete housing those servers.
Yeah.
They just open-sourced an AI model called BOxCrete. And my first thought was, why is the social media company messing around with wet cement?
It sounds totally absurd until you realize that Meta is building out physical data centers at an unprecedented global scale.
Right.
So BOxCrete stands for Bayesian Optimization for Concrete.
Okay.
It was developed on their adaptive experimentation platform, and its whole purpose is to intelligently navigate concrete formulations to predict the strength and workability.
What engineers call the slump, right?
Exactly, the slump of the concrete.
Okay, explain that Bayesian optimization part for me. How does an AI predict concrete slump?
So Bayesian optimization is a probabilistic model. Instead of relying on human engineers to just, mix a batch, test it, tweak the water-to-cement ratio, and try again.
The old trial and error.
Right. The AI looks at decades of historical mixing data. It calculates the exact chemical interactions and predicts the absolute highest probability of success for a specific recipe, even under specific weather conditions.
So it's like having an AI master chef who doesn't need to bake 100 cakes to see which one doesn't collapse.
Exactly.
The chef just calculates the exact molecular interactions of the flour and sugar to bake the perfect cake on the first try every single time.
Yeah, and the results are very real. I mean, this model accelerated concrete curing by 43% at Meta's Rosemount data center.
43%. That's huge.
It proves that AI is now actively solving real-world physical infrastructure bottlenecks.
Wow.
If we connect this to the bigger picture, Meta needs these massive data centers built as fast and efficiently as possible to house those 400 billion parameter Llama 4 models.
Right. The physical footprint has to scale alongside the intelligence. But pouring all that concrete and building these massive brains in the cloud creates a massive friction point. Well, how do everyday users actually interact with all that intelligence? Because pulling a smartphone out of your pocket suddenly feels very, clunky.
Yeah, it does.
And that leads us directly into Meta's consumer hardware updates from March 31st. They made a massive play for ambient computing with the Ray-Ban Meta Blazer and Scriber Optics Gen 2.
Right, so the official press release from Meta and EssilorLuxottica highlights that these are their first prescription-optimized AI glasses.
And they launch globally starting at $499.
And that emphasis on prescription-optimized is the critical detail here.
Because before this, smart glasses were basically novelty items, right?
Pretty much.
You wear them to a concert, record a quick video, and take them off because they give you a massive headache. But engineering them for comfortable all-day prescription wear,
It changes everything.
it changes the entire relationship with the device. And alongside the frames, they drop some huge software updates.
Yeah, the hands-free nutrition tracking.
Where the AI just looks at your plate and logs calories for you. Plus, end-to-end encrypted WhatsApp summaries and this feature called neural handwriting.
Ah, yes.
Okay, you have to explain the mechanics of neural handwriting to me because it honestly sounds like magic.
It does feel like magic, but the mechanics are purely spatial tracking.
Okay.
You basically write with your index finger on any surface, like your leg under a desk, a table, or just in the empty air.
Wait, just in the air?
Yeah, just in the air. The outward-facing cameras and sensors on the glasses track the micro movements of your finger joints and tendons. Then the AI silently translates those spatial gestures into text for your messages. You can seamlessly reply to a WhatsApp message during a crowded meeting without ever taking your phone out or speaking a single word.
That is wild. But, I mean, why go through all the trouble of engineering that? What's the end game?
The strategic motive here is what's truly fascinating. These glasses act as edge computing data ingestion nodes.
Okay, break that down.
By making the glasses your primary interface, Meta is attempting to completely bypass the Apple iOS and Google Android smartphone monopolies.
Oh, wow.
For the last decade, Meta has been entirely dependent on Apple's App Store rules and privacy walls. Now, they gain direct, frictionless access to your optical and auditory environment.
So they see what you see when you see it.
Exactly.
They're literally cutting out the middleman to get straight to your senses.
Ah.
But if they are ingesting all that real-time video and audio data from millions of glasses and serving you highly targeted ads based on it, they need incredibly fast software.
Hmm?
and software can only be so fast before it hits a physical limit. Which brings us to the adaptive ranking model for ads, published on the Meta Engineering blog on March 31st.
Right. This model is essentially the financial engine powering everything else we're talking about today.
Yeah.
Meta just fully transitioned its core advertising recommendation systems to a new LLM-scale adaptive ranking model. And the technical challenge they faced here is something engineers call the inference trilemma.
The trilemma being the balance between having a massive model, keeping latency super low so things happen instantly, and keeping the computing costs down.
Exactly.
Because if an ad takes an extra half second to load on your glasses or your phone, you just scroll past it and Meta loses money.
Right. And to solve this, Meta used advanced kernel specialization and dynamic routing, specifically a technique called advanced operator fusion.
Okay, unpack operator fusion for us, but, without the engineering jargon.
Sure. Think of how a microchip normally works. It performs a math problem, saves the result to its memory, fetches the next instruction, does the math, and saves it again.
Yeah.
All that stopping and starting takes tiny fractions of a second. Operator fusion allows the chip to combine multiple mathematical steps into one continuous fluid motion inside its fastest, closest memory cache.
Oh, I see.
It never has to stop and fetch data.
Yeah.
It basically neutralizes the latency penalty completely.
And what's the actual business result of that fluid motion?
A 3% aggregate increase in ad conversions globally.
Wow. Which,
Yeah.
at Meta's massive scale,
Directly translates AI research into billions of dollars in incremental revenue.
so what does this all mean? It means the billions of dollars being generated by that adaptive ranking model are immediately being poured right back into the physical silicon chips needed to run the whole cycle again.
Exactly.
And that transition from software to hardware is where things got really sci-fi this week.
The physical layer where the software literally meets the metal.
Right. So on April 2nd and 3rd, Meta introduced something called KernelEvolve, alongside a massive hardware team expansion.
Yeah, they hired veteran engineer Rui Zhu to build a dedicated hardware team inside Meta Superintelligence Labs.
But KernelEvolve is the thing I cannot stop thinking about. It is an autonomous AI agent that writes and optimizes low-level hardware kernels.
Let's define what a kernel is, just because it's vital to understand the leap here.
Please?
A kernel is the foundational, direct set of instructions that tells the physical silicon like the GPU exactly how to execute a calculation. Usually, elite human engineers have to manually write and meticulously tweak this code for every different type of chip. It is agonizingly slow, deeply manual work.
But KernelEvolve does this autonomously. It literally delivered a 60% inference throughput improvement for Meta's ads model on Nvidia GPUs.
It's incredible.
I have to pause here. Isn't AI literally writing the code to make itself run faster on physical chips? Isn't this the exact definition of recursive self-improvement?
It is absolutely agentic recursive optimization.
Wow.
Instead of a human spending weeks tweaking the code, the AI explores millions of configurations, compiles the code, tests it against the physical chip, and rewrites it in a continuous loop to maximize hardware efficiency.
That's just wild.
And it is essential because Meta operates a massive, highly varied fleet of chips, from Nvidia and AMD to their own custom MTIA silicon. The hardware landscape is so complex that they literally need an AI just to manage the hardware running the AI.
And speaking of that hardware complexity, just as they're getting AI to optimize their chips, they pulled off a massive strategic pivot.
Yeah, the Olympus chip news.
Right. TechCrunch reported that Meta officially halted development of their highly anticipated Olympus custom training chip.
Yeah.
Instead, they signed an external procurement deal with SMD worth up to $100 billion.
That AMD deal is designed to power up to 6 gigawatts of demand.
6 gigawatts?
Yeah, it exposes a very pragmatic reality about the chip industry right now. Designing custom silicon from scratch takes 3 to 4 years.
Right.
The manufacturing masks alone cost billions, and if you get the architecture even slightly wrong, you miss an entire generation of AI development.
Which they can't afford.
Exactly. Meta realized they can't wait 4 years. They are outsourcing the brute force training compute to AMD so they can scale immediately.
But at the exact same time they are securing 6 gigawatts of power to train these models, the human element threw a massive wrench into the machine.
Yeah, this is a huge story.
MSN and Mfear. The Next Web reported that Meta paused its AI training operations with a staffing partner called Merkur. And the reason why is deeply alarming. Merkur suffered a 4 terabyte data breach. It exposed the personal info of over 40,000 contractors. But more importantly, it exposed Meta's proprietary training data.
If we connect this to the bigger picture, you realize why Meta hit the brakes so hard.
Right.
In modern AI, the underlying architectures, like the mixture of experts we discussed earlier, are democratized. Everyone knows how they work.
Sure.
The true moat, the real secret sauce protecting Meta's $135 billion infrastructure investment, is something called RLHF, reinforcement learning from human feedback.
So it's not just pouring raw data into the machine.
Hmm.
It's the specific rubrics and grading scales that human contractors use to teach the AI how to behave.
Exactly.
It's almost like having a brilliant but feral dog, and the RLHF is the highly guarded obedience school training that makes it safe to be around humans.
That's a great way to put it. It's the behavioral guardrails. The human feedback rubrics leaked in that 4-terabyte Merkur breach are the atomic-level blueprints of the machine's mind and personality.
Oh, wow.
Exposing those rubrics allows competitors to essentially reverse engineer the personality of Meta's frontier models.
So you have this incredible friction. On one hand, Meta is scaling up hardware to 6 gigawatts and letting AI write its own kernel code at lightning speed.
Yeah.
But on the other hand, the slow, messy human element, the data labelers and contractors, creates this massive vulnerability.
It highlights a severe tension point. As Meta pushes the boundaries of autonomous infrastructure and ambient data collection with their glasses, the friction between its rapid technological scaling and its internal governance has reached a boiling point.
Which brings us to the most legally complex part of the week.
Yes.
As we move into this final segment, I want to step back for a second. We are about to look at some heavily scrutinized, politically charged leaks and landmark lawsuits. Just to be absolutely clear to you listening, our goal today isn't to take a side, left wing, right wing, or anything in between.
Right.
We aren't endorsing any viewpoints. We are simply here to look at the factual content of what was exposed in the source material this week so you can understand the complete picture of the legal challenges Meta is facing.
That context is vital because the regulatory environment shifted dramatically between March 29th and March 31st. Let's look at Meta's internal compliance first. They just announced an AI-powered risk review program.
Right. They essentially integrated their own AI directly into their core compliance operations. They transformed their old, human-led privacy review into a cross-company risk review.
It utilizes a strategy known in software engineering as shifting left.
Okay, what does that mean?
Instead of building a product and having lawyers check it at the end of the line, the internal AI automatically scans raw product code and proposals against a massive global library of data protection laws. It identifies privacy vulnerabilities long before products are ever launched. It's designed to accelerate the development cycle while theoretically mitigating regulatory risk.
But the irony here is incredibly thick. Because while their AI is meticulously scanning raw code for tiny privacy bugs, the human legal teams are facing an existential crisis in the courtroom.
Oh, absolutely.
CNBC and Forbes reported on 2 landmark jury verdicts this week. Juries awarded a combined $381 million in damages against Meta. And the way the plaintiff attorneys won is historical. They completely bypassed Section 230.
For context, Section 230 of the Communications Decency Act has historically been the impenetrable shield for tech companies.
Right.
It protects them from liability for content posted by their users, treating the companies merely as platforms, not publishers.
But these attorneys didn't sue over the user-generated content. They successfully argued that Meta's AI recommendation algorithms are defective products.
That is the crux of it. By arguing that the AI-driven recommendation engine itself is a defective product designed specifically to maximize engagement, eviction, or mislead users, they legally remove the algorithm from Section 230's protections. Reframing algorithms as defective products creates an existential threat to Meta's entire platform architecture. If they are held financially liable every time their algorithm makes a harmful recommendation, the financial risk is practically incalculable.
And that legal vulnerability was instantly compounded by intense political scrutiny over an internal policy leak.
Yeah, the 200-page document.
Right, a 200-page internal document leaked this week titled Gen AI Content Risk Standards. And it revealed that Meta allowed its AI chatbots to engage in romantic and sensual role play with children.
Following severe inquiries, a Meta spokesperson did confirm the document's authenticity, though they stated the company had already removed those specific sections, calling them wrong and inconsistent with our policies. Nonetheless, U.S. senators immediately launched a probe into the matter.
I just have to point out the glaring contradiction here. Meta is deploying advanced AI to meticulously scan product code for compliance with global laws in their new risk review program. Yet, a 200-page policy document explicitly approving AI romance with minors somehow makes it past senior legal and public policy teams. I mean, how does a company with a $135 billion infrastructure budget let that happen?
This raises an important question, perhaps the most important question of this entire deep dive.
Yeah.
There is a rapidly growing disconnect between Meta's breakneck innovation cycle, spending billions on hardware, launching 400 billion parameter models, and deploying self-writing code, and the societal and regulatory frameworks struggling to keep pace. The governance structures, both internal and external, are fundamentally misaligned with the sheer velocity of the technology.
Okay, let's bring this all together for you. In a single week, Meta revealed the blueprint for its entire future.
They really did.
We saw the deployment of massive 400 billion parameter models that require literal cities of data centers to run. We saw an AI agent autonomously writing self-optimizing code for physical silicon chips. We saw Meta pivot to a $100 billion deal with AMD, securing enough power to light up the grid. And we saw them use AI to perfectly predict the wet concrete poured to hold it all up.
And crucially, we saw the interface shift. They are taking that superintelligence and putting it right on your face with prescription AI glasses.
Right.
Ushering in an era of ambient computing where the AI constantly sees and hears your reality, attempting to bypass the smartphone entirely.
But alongside that incredible technological leap, we saw the human systems buckle under the weight.
Big time.
From the 4-terabyte Merkur data breach exposing the training blueprints of their AI's personality, to landmark legal verdicts classifying their algorithms as defective products, and Senate probes over unimaginable policy failures regarding child safety.
Which leaves us with a final concept to mull over.
Yeah.
If Meta's AI glasses succeed in becoming our primary ambient interface to the world, and their algorithms are constantly curating, translating, and dictating what we see and hear in real time, how will society possibly regulate a defective product when that product is literally our perception of reality?
Wow. That is a heavy, heavy thought to take with you. Thank you so much for joining us on this deep dive into the architecture of tomorrow.
Thanks for listening.
Keep questioning the rapid changes in the world around you, and remember to look closely at the invisible software shaping your physical reality. We'll catch you next time.